In this film, we're going to take a look at the Saginaw recirculating ball-type steering system used on many of our AMC and Jeep vehicles. If you're unfamiliar with power steering systems, I know you're going to be interested in the theory of operation information contained in this film. If you're pretty clear on power steering theory already, you'll find some excellent service tips in this program, tips you can use on the job. The expressions on the faces of these drivers pretty much illustrate the function of power steering systems. I think that either one of these guys would agree that the ease of operation offered by a power assist system is really appreciated in situations like this. In addition to making life easier for the driver, power steering also makes driving safer. Any system that gives the driver more control over his vehicle also gives him a safety edge in emergency situations. All of these AMC and Jeep vehicles equipped with power steering utilize the Saginaw steering gear system. All but the Jeep CJ use a variable ratio gear. The CJ gear is a constant ratio unit. Later in the film, we'll look at the differences between the variable and constant ratio gears. It's important that you remember that the CJ unit is different because, although the variable and constant ratio gears appear to be identical, internal components of the two gears are not interchangeable. Here are the components that make up the power steering system. The pump develops the hydraulic pressure needed to operate the power steering gear. The gear itself is a recirculating ball bearing type unit. In this film, we'll disassemble both the pump and the gear, study the theory of operation behind both units, then reassemble them. After we've looked at the gear and pump, we'll discuss some of the problems you may be asked to diagnose and correct. The most important part of any power steering job is the diagnosis. A thorough, precise diagnosis up front can save you a lot of time later on when you've got the system torn down. This slick little diagnostic wheel will help you diagnose problems in a Saginaw steering gear power steering system. 2 of these diagnostic wheels have been sent to your dealership along with this film. Later in the film, we'll see how this handy diagnostic aid is used. Before we disassemble the components, here's a tip that can save you a lot of problems whenever you work on a power steering system. It's important that the components themselves, your tools, and your work area are clean. Cleanliness is critical because if the components become contaminated, the system could fail again as a direct result of the contamination. Let's start with the gear. This illustration shows the principal internal components of the gear. The pump supplies pressurized hydraulic fluid to the rotary valve assembly. Depending on which way the driver turns the steering wheel, the rotary valve directs the pressurized fluid to the front or rear of the rack piston. When the rack piston moves, it in turn moves the pitman shaft gear and arm. Because the pitman arm is connected to the steering linkage, the front wheels also turn. Let's disassemble the gear so that we can see how it works. In this film, we'll cover the major disassembly and reassembly steps. Be sure to refer to the AMC or Jeep technical service manuals for complete, detailed procedures. Begin by rotating the coupling until the pitman gear is centered. Then unbolt the side cover and remove the pitman shaft and cover assembly. We'll discuss the function of the preload adjuster screw shortly. Insert a small punch through the excess hole and remove the end plug retaining ring. To unseat the end plug, strike it sharply with a soft hammer. Remove and discard the O-ring seal. To remove the rack piston from the housing, remove the rack piston plug, then insert ball retainer J21552 into the rack piston. Turn the stub shaft counterclockwise. This forces the rack piston onto the tool. The rack piston and tool can then be removed from the housing. Use a soft drift to loosen the adjuster plug lock nut. Then use a spanner wrench to remove the adjuster plug. Disassemble the adjuster plug assembly. As you can see, there are a number of individual components in the adjuster assembly. These include a thrust bearing retainer and spacer, the upper thrust bearing itself, a large and small bearing race, an O-ring, the adjuster plug and needle bearing, the stub shaft seal and dust seal, and a retaining ring. Grasp the stub shaft and remove the valve assembly and worm assembly as a unit. Then separate the valve and worm assemblies. Disassemble the valve body assembly. It's extremely important that you inspect and clean each of the components of the valve assembly before you reassemble the valve assembly. If any component other than the seals and rings is defective, the complete valve body assembly must be replaced. The reason for this is that the valve body assembly is a precision manufactured unit. All of the components are fitted to extremely close tolerances and balanced during assembly. Disassemble, clean, and inspect the rack piston components. Remove the pitman shaft retaining ring. Then use a punch to remove the seals and washers from the housing bore. Use special tool J21551 to remove the needle bearing. If it's necessary to replace the hose connector seats and poppet check valve, first pack the inside of the seats with petroleum jelly. This prevents chips from lodging in the ports. Then use a number 4 screw extractor to remove the port seats. Discard the seat and check valve and clean the housing thoroughly. Now that we've seen the insides of the gear unit, let's check out its theory of operation. This illustration depicts the action that takes place when the steering wheel is turned to the right. The torsion bar deflects, causing the spool to rotate in the valve body. The right turn grooves in the spool align with the pressure grooves in the body, directing high-pressure fluid to the left-hand side of the piston rack. As the rack piston is forced to the right, the pitman gear and arm try to turn the vehicle to the right. As resistance to turning increases, torsion bar deflection causes additional spool valve rotation. More right-hand turn grooves are exposed, and fluid pressure against the rack piston is increased. While this pressure is being exerted against the rack piston, the fluid in the upper and right-hand portions of the gear is flowing back through the valve body grooves to the reservoir. Here, the driver has turned the steering wheel to the left. The spool valve rotates in the opposite direction. The rack piston moves to the left, and the pitman shaft turns the vehicle to the left. And here's how the fluid in the upper and left-hand sides of the gear flows back to the reservoir during a left-hand turn. When the steering wheel is returned to a straight-ahead position, the torsion bar unwinds, returning the spool valve to its neutral position. Fluid pressure is equalized at each end of the rack piston. When the vehicle's moving forward, steering geometry assists the front wheels to return to a straight-ahead stance. Here is the chief design difference between the variable and constant ratio gears. All 3 teeth on the constant ratio pitman gear are identical. The teeth on the variable ratio gear and rack piston are of a different design. This variable ratio design facilitates a faster rate of turn. The result is easier handling during turning or parking maneuvers, and there's no change in the handling feel during straight-ahead driving. After you've cleaned and inspected all of the internal components of the gear, begin reassembly by installing a new poppet check valve and new connector port seats. This step only applies if you removed these components during disassembly. Install the pitman shaft bearing. Coat the seal lip and the faces of both washers with grease and install them in the housing. Then install the retaining ring. Reassemble the rack piston components. There are some very important tips in the technical service manuals regarding this step. Reassemble the valve body components. Then install the valve assembly and worm shaft in the housing. Be sure that the cupped thrust bearing races are facing in the same direction. Refer to the technical service manual for important tips regarding the adjuster plug reassembly procedure. Install the adjuster plug assembly in the housing bore until it's fully seated. Be sure to use tool J21553 to protect the adjuster plug seal. Install the rack piston and pitman gear and shaft. Again, refer to the tips contained in the technical service manuals. Now the gear is completely reassembled. At this point, there are two critical adjustments you must make to the gear. Shown here is the first step involved in the worm bearing preload adjustment procedure. Scribe a mark on the housing next to the spanner wrench hole in the adjuster plug. Measure 1/2 inch counterclockwise from the mark on the housing. Mark the housing. Then turn the plug counterclockwise until the reference hole on the adjuster plug is aligned with your second mark on the housing. Hold the adjuster plug in position while you install and tighten the lock nut. Here's how you adjust the clearance between the pitman gear teeth and the teeth on the rack piston. Be sure to refer to the technical service manual here. Here's a quick visual check you should perform before you install the gear in the vehicle. When the gear is centered, the flat on the stub shaft should face upward and be parallel with the side cover. Here's another important visual check. The master spline on the pitman shaft should be in line with the adjusting screw. Now we'll tear the pump down and see how it works. Before you disassemble the pump, be sure to clean the exterior of the pump thoroughly. Then begin by removing the pulley. Install the pump in a vise. Don't over-tighten the vise because this might cause bearing distortion. Remove the pump union and mounting studs. Discard the seals and O-rings. Remove the reservoir. Remove and discard the mounting stud seals, union seal, and O-ring. Refer to the technical service manuals for the rest of the pump disassembly steps. When you have the unit completely disassembled, clean and inspect all of the components. Here is where the pumping action starts at the rotor vanes. As you can see here, the vane tips follow the inner cam surface of the pump ring. Because of the eccentric design of the cam surface, the vanes move in and out twice during each rotation of the pump. This action produces 2 complete pumping cycles with each revolution. As the vanes move outward, low-pressure fluid is drawn between them through the intake ports in the pressure plate and thrust plate. As the vanes move inward, high-pressure fluid is discharged from the pump ring. Part of the fluid flows into the discharge cavity through ports in the pressure plate and thrust plate. The rest of the fluid is circulated through the central port system in the pressure plate. This pressure forces the vanes to follow the cam surface. The flow control valve bypasses the fluid within the pump when fluid flow exceeds predetermined system requirements. The flow control valve is also responsible for limiting the temperature of the fluid. When the vehicle is traveling straight ahead, the fluid flows back to the reservoir without traveling through the gear. This action lowers fluid temperatures. When wheel movement is blocked by objects such as curbs or mud buildups, the pressure buildup in the gear causes all pump pressure to be directed into the pressure relief orifice. When fluid pressure exceeds approximately 1250 psi, this pressure overcomes the relief valve spring tension. The check valve ball is then unseated. Pump output pressure is now rerouted back to the reservoir. Begin reassembling the pump by installing the pump shaft seal with the special tool shown here. Reassemble the thrust plate, rotor, and pump shaft components. Be sure to apply petroleum jelly to the outside diameter of the rotor. Install the pump shaft assembly in the pump body. It's extremely important that the rounded edges of the vanes are against the cam surface. Be sure to lubricate the pump ring and vanes with petroleum jelly. Install this seal in the pump housing, then install the pressure plate with the spring groove facing up. To seat the pressure plate, press down on it with a large socket. Install the spring in the center of the pressure plate. Then install the end plate in the second groove of the pump body bore. Lube the end plate with petroleum jelly, then press the end plate down until you can install the end plate retaining ring. Install the spring on the hex end of the flow control valve. Then install the valve assembly in the pump bore with the hex end facing the interior of the bore. Install the mounting stud seals and pump union seals in the pump body. Then install a reservoir O-ring on the pump body. Lube the inner edge of the reservoir, then install the reservoir. Install the mounting studs and pump union. Finally, use the special tool here to install the pulley. So that's what the Saginaw steering gear system gear and pump look like. Now let's get into the area that's most important to us as service technicians. Let's see what service procedures are needed to service the system. External fluid leaks are pretty easy to correct. If you have occasion to isolate and eliminate a leakage problem, begin by wiping the gear, pump, hoses, and all connections dry. Make sure the fluid level in the reservoir is correct, then start the engine and turn the wheel in both directions a number of times. If the leak is in the area of the adjuster plug, inspect the area closely to see if the leak is due to a defective torsion bar O-ring. Check the technical service manual for the procedures required to correct your particular leakage problem. Whenever you receive a customer complaint regarding a power steering system, always check the areas outlined here. These are all potential problem areas that, although they are easily corrected, are often responsible for power steering complaints. Always check the fluid level and condition. Make sure the belt tension is within the correct specifications. Check for loose mounting bolts and a loose pump pulley. Here's a tricky one. Make sure that the hose coupling isn't rubbing on the adjusting screw. And finally, check the pressures of both front tires. There are a number of customer complaints that you might receive regarding the Saginaw steering gear power steering system. The customer may be experiencing a loss of power assist, or he may have a hard steering problem only when the vehicle is cold. This condition is sometimes referred to as morning sickness. Sometimes a problem can develop that only shows up once in a while in the form of momentary steering effort increase. You may come across a situation where the steering turns by itself. Like the other potential power steering problem areas, there is a definite cause for this condition. Sometimes a condition develops where the steering wheel won't return to its center position. We've all seen cases where the steering wheel surges or chatters. You might even come across a power steering malfunction that results in a pulling or wandering condition. The diagnostic wheel you received with this film is designed to help you pinpoint causes of any of these potential conditions. I hope you'll make use of it because it can save you tons of time when you're looking for problem sources. The diagnostic wheel will, in some cases, suggest that you perform pressure tests on the Saginaw power steering system. Complete instructions for these tests are contained in both the AMC and Jeep technical service manuals. Let's run through a situation where you can make use of the diagnostic wheel. Suppose our customer is reporting a loss of power assist problem. First, the wheel suggests A, the 6 basic checks, which are outlined right on the front of the diagnostic wheel. So, the first thing we'll do is make the 6 basic checks. The fluid level and condition are okay. The belt tension is within specifications, and the mounting bolts and pump pulley are all okay. The coupling's clear of the adjusting screw, and the tire pressures are okay. The wheel says to refer to category N for our second check. The various check areas are all detailed on the back side of the wheel, along with the recommended fixes for each area. So what we do now is check for kinked hoses or tubes. If the hoses or tubes are okay, then we go back to see what step 3 is. When you're using the diagnostic wheel, just follow these steps, and I think you'll isolate your problem a lot quicker. Well, that's the Saginaw steering gear power steering system. I hope I've helped you understand the system a little better. If you use your diagnostic wheel when you're tracking down a problem, I think you'll find that things go a lot quicker. Remember, your Jeep and AMC technical service manuals are your most comprehensive sources of information on the Saginaw power steering system. Also, be sure to attend the AMC service training course on this system when the course is held in your area.